All right, so let me review with you. Because you know we've done a ton of stuff with proving triangles congruent. So I'll tell you triangle ABC congruent to triangle DEF. All right, I'm gonna let you guys take over. What else is true then? If those two triangles are congruent, what else must be true? Come on now, we haven't used all this time this year. If the triangles are congruent, what else do you know is true? Jonathan, hello. Angle A congruent to angle D. Good. What else is true? Serena.
Angle C is congruent to angle F.
Okay, C and F. I don't need anybody to tell me B and E now. Anything else true? B. What else is true?
B and A, B and D. Like line.
Yeah, thank you. Use your big words there. BA congruent to ED. All the sides and all the angles are equal, correct? When the triangles are congruent. All right. Now, what happens if, let me go back to A, B, C, and D, E, F. What if two triangles are similar now? Well, good news, the angles are still equal. The angles are still equal. So A congruent to D, B congruent to E. What changes? The sides aren't congruent though. The sides are not congruent anymore, unfortunately. All right, so when two triangles are similar, yes, the angles are equal, but the sides are not congruent. They are in the same ratio. Here's what I mean by the same ratio. Let's go 3, 10, and 8 for my sides of ABC. That side's 15. The side that AB matches up with ED is 15. What does that mean? All the other sides are going to be in the same ratio. So if AC is 10, what should the length of DF be? This was 3. Its corresponding side was 15. All the other sides are going to be in that same ratio. So 8 and, oh, hi, Tammy. Thanks for raising your hand. Look at this.
40.
How'd you get 40? Oh, you're right. Never mind.
Yeah.
I got to relax. I was thinking, relax, everybody. All right. And if BC is 10, how long is EF going to be then? Jonathan? 50. Corresponding sides are in the same ratio in similar triangles. The angles are equal, but the sides are not. The sides are in the same ratio. How do I write that they're similar? Triangle, ABC. My rule still applies as it did for congruent. You still need to match up the congruent angles and sides. All right, you still need to match up the congruent angles when you write it. Anybody know the sign for similar? Nobody's known it today. You would be the first group to know it. Hi, Quan.
Is it an S but sideways?
That's the most non-mathematical description I think I've ever heard of it. Yes. Everybody think of the congruent symbol. Think of the congruent symbol in your mind. Take away the equal part. See what's left? Oh, and you guys know the name. Some of you guys know the name. Tilde. Yes, tilde. Not squiggly, not worm, not S rotated 90 degrees. Tilde. Use it, please. Use the vocabulary. Everyone all right? Okay, last thing I need to talk about is what's considered the scale factor. Scale factor. That's the ratio of two corresponding sides. All right? They're all in the same ratio. I just need you to pick two corresponding sides, give me the ratio. They're all in the same ratio. You just got to match them up correctly. So here's my first question to you today. Going back to the numbers. I know you love it. 4. Who's got 4 in the house? Griff, that's you? Can you name two corresponding sides for me?
AB's corresponding to DE.
Okay, so AB and DE are in a ratio. What's that ratio? Well, what's the side lengths? Griff, go back to you. What's AB? How long?
3.
And how long's DE?
15.
15. And if we reduce it, The scale factor would be 1/3, 1:3. Okay? And everyone agree all the other corresponding sides are in that same ratio. 10 over 50. Why did I put 1/3? 1/5. God, I am on fire today. Rattled. Get back in it. This is unacceptable honors teaching, correct? I'll say it. I expect honor stuff from you. You should expect the same thing back. Everything else, 1 to 5. All good? Questions? So if two triangles are similar, angles are equal, sides are in the same ratio. All good. I'm going to be on fire the rest of the day, so buckle up. Let me go back to my congruent triangles. Hey, let me go back to my congruent. I know it's not in your packet. Just relax. Let me go back to my congruent triangles here. What am I going to ask you? If I just wrote this here, I wrote 5 up there. What am I going to ask you right now? Hi, Caitlin. Go ahead. You got anything you want to start? Come on, let's go. What do you got? Right? 5 ways to prove triangles congruent. Well, how do I prove 2 triangles similar now? 3 ways. 3 ways. And you guys are going to love the first way I show, which is right up on your notes. The first way to prove triangles similar is AA, which stands for angle, angle. That is all you need, kids. 2 pairs of angles, they're similar. That is it. By the way, why don't I need a 3rd pair? Why isn't it angle, angle, angle? Why is 2 sufficient enough? Why don't I need the other A?
Third angles theorem.
Oh, look at this guy. Look at this guy. Good job. Get out of here. Come on. You like you're going to get compliments from this guy? No. And I'm still fired up. I made all those mistakes, so that's why too. Yes, correct. If the 2 of the pair are equal, the 3rd pair have to be equal. So that's why it's not angle, angle, angle. All right. So everyone see my diagram here. I marked angle B congruent to angle Z and angle A and X. They're similar. They're similar right now by angle, angle. Quick 2-column proof, because I know you missed them. We're not going to get really hardcore until Monday. All right? We're not going to get hardcore until Monday. Prove to me why these 2 triangles are similar. Wait, you didn't even give me anything. Yes, I did. Look at the diagram. What 2 angles did I give you already congruent? H and S are congruent. All right, turn it over to you guys. What else you got for me? What else you got? Well, settle down. 8, got anything for me? Thank you. Oh, can't tell you how many people would still tell me, oh, O is congruent to O, reflexive. Nope. Vertical angles congruent. Okay, guys, do you have 2 pairs of angles? Triangles are similar. Triangles are similar. Triangle UOH. Guess what habit you're going to have to break? And some of you are noticing that you're going to have to break it. Your brain and hand automatically write what next? Oh, congruent. Yeah, get those erasers out. Similar, you're better than that. It'll take a little bit. It'll take a little bit. UOH, congruent to EOS. Just did it myself. Similar to EOS. Angle, angle. That's all I got to write. That's not bad. What's up? What's your deal?
I just have a question. How do we know that the triangles couldn't be congruent?
They could be, but I don't have enough information.
Okay.
I would need a side, right?
Yeah.
And I don't have any sides.
Okay.
So the bare minimum I could say is that they're similar. because I have two pairs of angles. Good? Because angle, angle, angle is not a way to prove congruent, right?
Mhm.
Okay. Everyone good? Angle, angle. Method number 1. Method 2, you ready? Looks pretty familiar, doesn't it? What's method 2? Side, angle, side. Oh, it's not the same side, angle, side you're used to, though. The angle, yes, is congruent still. So look at my diagram here. What two angles are congruent to each other in my diagram upstairs here? R is congruent to S. So that, yes, the angle needs to be congruent, but the sides surrounding them are not congruent. The sides surrounding them are in the same ratio. Here's what I mean. Can somebody just yell out a side length that we know in one of the triangles?
Yes.
Can I get the number? 18. So 18 over, what would the 18 correspond with over here? What's the bigger side? 12. Is the ratio of 18 over 12 the same as the ratio of, what's the other side from this triangle I know? 15 over, what's the 15 correspond with? 10. Are they in the same ratio? Now, I have to discuss this with you because I don't think some of you guys really understand how can you tell if they're in the same ratio? Because to me, 18 over 12 and 15 over 10, they look like totally different numbers. Anybody know how you can test if they're in the same ratio? Okay, John, go ahead.
You just simplify both fractions.
Grab your calculator, everybody. Grab your calculator. Do your fraction. Get a fraction template up. Alpha y equals. Do 18 over 12. The calculator will simplify it for you. Then do 15 over 10 using a fraction template. They simplify to the same values? Yes. So that's why they are similar by side, angle, side. The angles are still congruent, and the sides around them are in the same ratio. All good? Questions, comments? Side, angle, side. All right, down below. Do you know of any angles that are equal? Yes, you do. What angles are equal down below? 10 angles that are equal.
A and D.
Okay, A congruent to D. I'm not doing a proof here. I'm just letting you guys see where side, angle, side comes from. All right, the angles are congruent. Now, show me the sides around them are in the same ratio. Give me a side length, you know. 13, give me a side length, you know. How about 4? Side length, you know, Griff. 8. Ready? 8 corresponds with what in the other triangle, Griffin? 6. So does 8 over 6, is that in the same ratio as the other two sides? 4 to 3. If they are, side, angle, side. If they're not similar. So again, 8 over 6 in your calculator gives you a fraction, which should match 4 over 3, I believe. So are these two equal? Yes, they are. So triangle BAC is similar. Make sure, I know, break the habit, break it. BAC similar to EDF by, and I'm going to require you do this, and I want you guys to tell me why I'm going to require it. By side, angle, side, and I want the tilde with it. Why? Why am I requiring the similar symbol next to it? Matt, go ahead.
Because you could be saying they're congruent.
If I eliminate this, side, angle, side like that, that's for congruent triangles, and we're not proving triangles congruent. So I need that in there to say, hey, we're proving the triangle's similar. Good job. Angle, angle, side, angle, side. Third and final method. Look familiar? Yes? Side, side, side. But am I saying all three sides are congruent? No. I'm saying all three sides are in the same ratio. So I need to check all three pairs of sides to see if they're in the same ratio. How do I do that? All right, let's take a look at my two triangles I gave you. How do you test if they're all sides are in the same ratio? All right, let me talk to somebody. 1, give me a side length. Okay, give me a side length.
26.
Okay, 26. Now I got to figure out what does 26 correspond with in the other triangle. Now, I'll admit something right now. Even as a math teacher, I hate to move things visually and flip them visually to see where everything matches up. I can't stand that. So you know what I do? I take the easy way out. 26 is the biggest side here, right? So it should match up with the biggest side over here, which is 13. Is 26 over 13 the same ratio as, give me another side. 8, another side.
16.
Okay, 16. You guys tell me now, what should the 16 match up with? 8. Hey, don't stop. Now, I know some of you look at it and go, oh, those are the same. We're good. No. What's the method called again? Side, side, side. Just because you get 2 of them right in a row doesn't mean squat. You got to check the third pair, which is what for us? 10 over 5. Got to have all 3 for side, side, side. 2 out of 3 won't cut it with me. Are they all in the same ratio? Yep, 2 to 1, 2 to 1, 2 to 1. Yep. So that checks out. So that's why it's by side, side, side. Last one, I don't really want to say it's the 4th method. I just want to put it in your mind in case you get desperate on a quiz or test. We've never done that before, have we? Here got desperate. We had like a 4-step proof into like a 13-step proof. If you can prove the triangle's congruent, this is kind of what Avery was mentioning before. If you can get the triangles congruent, they are also similar. All right, so say if you're blanking on a proof, but all of a sudden a light bulb comes on and says, wait a second, I can prove those triangles congruent, then they're similar as well. Okay, all good? So congruent triangles are similar, but not the other way. Group work time, here we go. I want you to go one at a time. You and your group, number 1. Are they similar? If your group's going to say yes, you have to write a statement saying they're similar and give me one of the 3 methods. Go right ahead. Talk it over. First of all, if it's a yes or a no, you got to decide.
Angle. So I'm gonna write yes. Triangle.
Then write the similarity statement and the reason why.
R X Q because angle.
Don't write the congruent sign.
The second one.
That was an A.
12 and 12 match up. Wait.
12 and 12 don't match up. 20 and 15 do. And then 9 and 12 and 16 and 12.
Okay, wait. So it's 20 and 15.
You only need 2.
16
We
and
do
12. 12 and 9.
Okay.
All right, going back. Groups. 7. Similar or not?
Yes.
Yes. I'll just write my own statement. It may differ from yours, but that's fine. Just make sure everything matches up. So I'll go AXB. Similar. Everyone double check. Do you have the similar sign? AXB and RXQ. All right, back to 7. By what method? Angle. I only see one pair of angles. Where's the other?
Angle AXB is also congruent to angle QXR because of vertical angles.
Good, perfect. Everything I needed to hear. Any questions? Go ahead, go to 2 now. Go ahead, 2 in your group. Yes, no. If it's a no, discussion's over. But if it's a yes, what's the method? Write a statement.
I said yes. Because of side, side, side.
But you have to make sure if you use it, put the 20 The angle has to be.
I like the smaller one.
You get
Well, you
it.
keep it also.
But you
You
can,
can do side angle side on side.
but you, if you do, side angles are higher. I can't do
Oh, wait, no. And the last one is. That's congruent. And has 4 over 3 over 4, right? That's not gonna be. This is gonna be 1/2.
All right, let's talk.
So this one, last one's.
Oh, 5. We said yes or no. Okay, I agree with that. Yes.
Don't.
Triangle, I'll do my version. XPM, similar to XPM AWL. What'd you guys say, Greg?
SAS.
All right, that's one way. SAS similarity. Anybody do side, side, side? Nobody? Okay, yeah, you can do side, side, side. Are you, now here's my question. Are you okay on checking if the sides are in the same ratio? Are we okay there, checking? Whether it be all 3 sides or just the 2 sides that surrounded the right angle, making sure they're in the same ratio. We're okay? Because that's my biggest worry, is writing a proportion, this unit. Okay? And I'll just write this, or side, 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 similarity. All right, you're on number 3 now. Similar or not?
It's not.
I was going with that. You all right still rolling solo? Okay.
It'll be 2.
Claire, what did you get?
All right, here we go. What do we think about these two? 6.
No.
Nope. The only thing it could possibly be is side angle side, right? Only thing it could possibly be because you got your vertical angles. But when you tested the numbers, well, however you set up your ratio, let's see, 4 on this side matches up with 3 on the other side, and 8 on that left matches up with 4 on the right. It's not going to happen. Everyone agrees? It's not going to happen. Okay, so that doesn't work, so they're not similar. All good. So you proved triangles similar. Now to end class, what I want to do in your group is, I'll tell you they're similar. Here's 3 sides, find the 4th missing side. That's what I'm going to do with you now. You know they're similar. Here are 3 out of 4 sides. What's the 4th side? So you and your group are going to have to set up your own proportion. All right, I am going to skip 1 because I think 1's probably the toughest out of almost all of them. So can we go to number 2? This, in my opinion, is the most difficult part, is coming up with a proportion to solve. Right off the bat, I tell you these two are similar, right? So sides are in the same ratio. Everything's labeled. I'm looking for the length of ML. How long is ML? Now you have to come up with your own proportion. You know the sides are in the same ratio. All right, let me show you how I build mine. You may not build it the same, but let me show you how I build mine. I first go to the triangle, which I'm trying to find the missing side for. So I'm going to go to triangle MLN, and I see that 2 of the sides are X and 7. So I start with the triangle I'm trying to find one of the sides for. And I write down 2 of the sides. Equals, now I figure out what each side corresponds with. What does X correspond with on the bigger triangle? And again, here we go, right? I can't visually move that. I don't want to visually move it. So you know how I have my little cheat code? Use the statement. Remember doing that for congruent? ML. ML should be equal to what over here? Look where M and L are in the statement. What letters are in the same spot in this statement? R and Q. So what is X corresponding with? RQ, which is 30. What's LN, 7, going to correspond with then?
21.
LN should be QS, which is, yes, Jonathan, 21. Put your pencils down, pens down. I want to make this clear. This is not the only proportion you could have set up. You could have done it this way. I see kids do it this way. They take a side, x, then they say what it corresponds to, 30, and they take another side from the triangle, 7, and tell me what it corresponds with, 21. Hey, look at my two proportions. Am I still cross-multiplying the same things? When I go to cross-multiply, am I still cross-multiplying the same things? Yes. I want to make it clear, guys. You may do this differently than I do, but we're still at the same answer. All right, so there's different ways to set up the proportion. Go ahead and solve it. Go ahead in your group. I want you to solve it, then go on to number 3.
So 21x.
Just be lucky you're not factoring these yet.
360. Oh, wait, 6.
So go ahead, answer that question, and then go ahead on to number 3.
You just divided 21 by 7. Divided 30 by 3. Because 21 divided by 7 is 3, and then just divide 30 by 3.
Yeah.
10 is 12.
The state of a triangle measures the side of the triangle 7, 4, 9. Okay, wait. So let me draw that. 7,
You're at
4,
16.
9. Longest side of the same triangle.
And then go on to number 3.
I'm trying to find that.
That only.
Okay, can I have a proportion from somebody that you set up for number 3? X equals 10 for the previous problem. How about a proportion that you set up to solve for number 3? Oh, 19?
36 over 9 equals x over 4.
That's a good one. But guys, look. Who gave me that, Caitlin? That's Caitlin's. It may not look like yours, but are you cross multiplying 9 and x and 36 and 4? Because if you are, you got a good proportion in front of you. Okay, got a good proportion. 9x equals 144. X equals 16 here. All good? All right, now I think you're ready. Go back to question 1 and try it out in your group. Go back to question 1, try it out in your group. They're similar. They're similar. Which one is not correct? No, or which one is correct? Excuse me. This really shows if we know how the proportions should work. Which one is correct? I like the discussion here, some groups here, discussions. Okay, any nominations? I got a nomination for 3. No, I heard other numbers thrown out there. 3's the only nomination. I heard 4 out there. Good talk. We'll just stare at each other awkwardly. Well, let me go 4 first. Let me go 4. 32 and 12. Everyone agree they match up? That's no issue, right? 32 over 12. I can put 32 over 12. Where's the issue? Here, right here, 15. Why is that an issue? Do they come from the same triangle? No, they do not. Okay, and no, they do not come from the same triangle. I would need to flip this for it to be true. Yes, the correct answer is 3. Okay, the correct answer is 3. Let's put it this way. You should never be cross multiplying 2 sides together. Okay, they shouldn't be diagonal from each other. They should be on top of each other or across from each other. Okay, they should not be diagonal from each other. So you should never be cross multiplying 2 sides from the same triangle. All right, how are we feeling, all right? All right, one more with you, and then I want to do a homework problem with you as well. Okay, this one deals with perimeters. And instead of trying to read it and explain it, I want to show you with numbers. Do this for me. On quadrilateral ABCD, can you do AD as 1, AB as 2, BC as 3, and CD as 4? And then jump over to quadrilateral JKLM. JM 2, JK 4, KL 6, ML 8. Quickly, not in your groups, just by yourself. Quickly, can you find the perimeters of each for me? And write it inside each quadrilateral. Find the perimeters of each and write it down for me. So you got 10 and 20. What am I trying to show to you here? What's the ratio of their sides? Of the quadrilaterals, what's the ratio of their sides? All right, if you're going that way, right? All right, if you're going bigger or the smaller, yep, 2. I'll go this way though. 1 to 2, everyone agree? What's the ratio of their perimeters? 10 to 20, which reduces down to what? 1 to 2. So whatever the ratio of the sides are, it's the same ratio their perimeters are in. That's what I'm trying to show you right now. Whatever the ratio of the sides are, it's the same ratio as the perimeters. Let's make that sink in right now with problem 4. These 2 quadrilaterals are similar. I want to know the perimeters of each now. What's the perimeters of each? Well, can you quickly find the perimeter of the bigger one? That shouldn't be an issue. The perimeter of the bigger one? 34? All right, well, what's going to be the perimeter of the smaller one then, without finding the other 3 sides? Can I do that without finding the other 3 sides? Yep. This side of 4, WX, corresponds with what? Look at the statement if you don't know either. Ooh, WX corresponds with MQ, which is 8. That right there is the same ratio as the perimeters. What are the perimeters? I don't know for the smaller one. That's what we're trying to find. And the perimeter of the bigger one? 34. The ratio of the sides is the same as the ratio of the perimeters. That's what allows me to set them equal. And now you can cross multiply, solve for the perimeter of the smaller one. Perimeter of the smaller one?
17.
Yeah, right? Should be half the perimeter because all the sides are half. Any questions on the perimeters? One more big piece of information I need to give you before we end it for the weekend. Go to problem number 2 on your homework. 2. Problem 2. Go ahead, fill in the side lengths for me. Fill in the side lengths. AB is 10. BD is 5. DE is 12. What is the length of BC? Guys, do you see 2 triangles in that diagram? Do you see the 2 triangles? 2 triangles in the diagram. Triangle ABC and triangle ADE. Do we see them? They're similar to each other. Now what we need to do is match up their sides. And here's the point I want to get across. When you create your proportion, you are only allowed to have full sides of the triangle. Do you see BD is 5? What? 5 should never appear in your proportion. Why? It's not a full side. Only full sides are allowed in the proportion, not partial sides. All right, you ready to build this for me before we go? Thirteen. 21. 21. Hi, how are you? Okay, here's what I want you to do for me. Name one triangle in this diagram. Okay, name the 2 sides you know. And? Okay. That's how I'm going to, again, you may not start like me, but that's how I'm going to start. Now I got to figure out, what does 10 match up with in the bigger triangle, ADE? Not 5. That's not a full side. What does 10 match up with in this full triangle ADE? A length of, come on, be there. 19? 19? I can't. Yes, 10 and 5. Everyone see that? 10 matches up with a side length of 15. And this is easy now. What's the X match up with in the big triangle? 12. You cannot have partial sides in your proportions. And then you guys can take it from there. All right, you can take it from there and then start with a couple more, I guess. Oh, geez.
Please excuse the interruption. French Club is canceled for today. Again, French Club is canceled for